Alright, so we are doing 6.2, Simplifying Radicals, Part 1 for this chapter, for this unit. Notes and assignment all in one. So, number 1 is negative radical 5 plus 2 radical 5. So, the answer to this question is 1 radical 5 or just radical 5. I want you to take a second and think about why that could be, or how that could be. I'm going to give everybody 1 minute to think about how we went from this to this. All right, talk to the person sitting next to you, or behind you, or maybe you have the thought and you can just join in over here. Time's up. Who can share? Liberty?
Okay, so there's a negative 1 in front of the first radical 5, and negative 1 plus 2 equals 1.
Nice job. That's well done. So the tricky thing here is it's kind of like with variables, negative x plus 2x, we would add those coefficients, negative 1 plus 2. The x would stay the same, right? Same thing here. We don't add the 5s together and get a 10 underneath. It stays the same. Sam?
So, how do we get that equal sign?
Oh, here I just did 1 radical 5 equals radical 5. They're the same thing. So I just simplified it further.
I'm just confused because it's one equation.
It's one expression, there's no equal sign, right? But I'm just saying these two are the same thing, so I just wrote it in a simpler form. Number 2. Try number 2 on your own. Raise your hand if you got what I got. Awesome. So in this case, we're adding these coefficients. The radicals are the same, which is the qualifier to be able to combine those coefficients, just like with x's. They're like radicals, you could say. So negative 5, radical 5. Number 3 is a little different because when you look at radical 18, hopefully you're thinking a thought that radical 18 can be simplified. And I can look for perfect square factors of 18. 9. So I could write this as radical 9 times radical 2, which would then simplify. Square root of 9 is 3, so I could write this as 3 radical 2. Remember this? It builds. It's coming back. So when I go back to bring the 3 radical 2 in to my expression here, I substitute the radical 18. I keep the negative 3 here, and then just replace that radical 18 with 3 radical 2. And then minus 3 radical 2. Negative 3 times negative 3 is 9.
That's okay.
This was a negative 3. So that stays. And then, do you see where?
Yeah,
Okay. So negative 9 minus 3 is negative 12. So we have negative 12, radical 2. -9 minus 3.
Oh, okay.
So you don't change the signs, like, I don't know. Doing +9 both sides. You don't do that.
There's only one side. So we're just combining those like terms. Try number 4. Try number 4 on your own. So hopefully you had a thought about radical 8 and broke that into radical 4, radical 2, which then simplifies to 2 radical 2. So I can rewrite this first term as 3 times, replace the radical 8 with 2 radical 2, which then becomes 6 radical 2 plus 2 radical 2 equals 8 radical 2. Did you get the 2 radical 2 part?
No, I got 1 radical 2.
So did you break it?
I broke it down and put the radical 2 and radical 4.
So radical 4 is 2.
Yeah, but those were like switched. I put the 2 first.
So you did like this?
Yeah.
So the radical 4 is still going to turn into a 2, right? So since that's a 2, the correct way to write that is with the number in front. So it should still be 2 radical 2.
But just
Only the one that's the perfect square can be simplified. The square root of 2. The square root of 2 is not a perfect square, so this is the radical 2. The square root of 4 is 2. You did divide by 2, I think, to get 1. But that's not what square root means. It means what number times itself equals that thing. Next. Number 5 we're going to skip, but just a sneak preview. You do need to simplify the radical 27. Skipping 6. I'll do 7 since there's 3 terms here. The first term can't be simplified, but the second one can, so radical 12. So we're looking for perfect square factors. I like to write the perfect square first because then it lines it up to be in the right spot. That's a 3. So radical 4 times radical 3. And then square root of 4 is 2. So that simplifies to 2 radical 3. Here, the radical 8. We just did that, didn't we? So radical 4, radical 2 turns into 2 radical 2. When you start to notice, oh, I've already done that one, you don't have to redo the process. You can just go back. And sometimes you start to see them enough that you know that radical 8 is going to be 2 radical 2. Now I'm going to bring it back into the expression and simplify. So 3 radical 2 stays, minus radical 12 turned into 2 radical 3, and then plus 3 times 2 radical 2.
Wait, where did the 3 times? Oh.
I know it's easy to forget those coefficients. Don't forget. So then that becomes 3 radical 2 minus 2 radical 3 plus 6 radical 2. I can combine my like radicals and get 9 radical 2 minus 2 radical 3. So you can, final answer, notice, is a little bit different because there's 2 radicals, but they have different values in the radicand spot, so we can't combine them any further. So that's our final answer. Because I can't combine it with the 9, since they're different numbers underneath. Next up, on the back, there's a divide after number 10. Number 11 is a new section of simplifying, still simplifying. But specifically, we're going to be rationalizing the denominator. And that's going to happen in 3 steps. Step number 1, simplify. Step number 2, we're going to multiply the numerator and denominator by the, I'm using as many abbreviations as possible so I can fit it in, by the radical from the denominator. So multiply the numerator and denominator by the radical from the denominator. And step 3 is simplify. Again. So 11, we can't simplify anything. The 9 and the 6, we can't simplify since the 6 is under the radical. So it's off limits to just simplify that with the 9. So we jump to step 2. The thing about radicals in the denominator, that is not considered the simplified form of a fraction. You can't have radicals in the denominator. Okay? So let's write that. In order to be simplified, you cannot have a radical in the denominator. So what we're going to do is multiply the denominator by radical 6 and the numerator by radical 6. And we do that because radical 6 times itself is radical 6 squared. The numerator, just multiply numerator times numerator, so that's 9 radical 6. The squared and the square root, just like we did yesterday, cancel out. So I have 9 radical 6 over 6. We're clear, we don't have a radical in the denominator. We can simplify one step further. We can divide numerator and denominator by their GCF, which is 3. And that's my final answer. Number 12. From the beginning, I look at radical 8. We've seen that a couple times already. So I know radical 8 actually simplifies to 2 radical 2. Who remembered that from the front? Radical 8 is 2 radical 2. So I'm going to come back and rewrite this as 5 over 2 radical 2. Next step is to multiply numerator and denominator by the radical from the denominator. So I have to multiply numerator and denominator by radical 2 over radical 2. So that'll be 5 radical 2 over 2 times radical 2 squared. Radical 2 squared, remember those cancel out, so I just have 2. Final answer, 5 radical 2 over 4. One last tip before I let you work on your own. Here's your tip for the day. To multiply radicals, so when we multiply radicals, such as radical 5 times radical 3, any guesses on what that equals? 15? Just plain 15? Yes, radical 15. Okay, so it's kind of intuitive, but I just want to make sure everybody knew that, because that will come into play on question 15. And that is our lesson on 6.2, Simplifying Radicals, Part 1.